Hello and welcome. Today's lesson we're talking about ratios, proportions, and similarities. So let's jump right in. A ratio is a comparison of two numbers. And we can write it several different ways. So I'm actually going to put numbers or variables in the definition. So let's say I want to compare 2 to 3, for example. So I can write 2 to 3 in words like that. I can also write it with a colon, 2 to 3, or I can write it as a fraction, 2 over 3. A proportion is an equation involving two or more ratios. Pardon me. So if I wanted to say, use my example of 2/3, I could say 2 to 3 is the same as 4 to 6, or we can do an extended ratio, and maybe I could say 2/3 is equal to 4/6 equal to 8/12. Okay, so it's just setting those fractions equal. So our next thing is talking about properties of proportions. So if I know that I have a proportion, A to B equals C to D, then I know it's also equivalent to these other equations. So AD equals BC, B over A equals D over C, A over C equals B over D, and A plus B over B is equal to C plus D over D. We can prove all of these using algebra. So when I do an algebra proof, we're going to just do the first one together. So I start with the if. So the if is always the beginning, and then the then is my goal. Okay, so our goal is to get to AD equals BC. So if I start with A over B equals C over D, and I want to look at where I'm going, I need A times D. Well, if I have A times D on the left-hand side, then I'm going to multiply by D on both sides, which is nice because it will cancel that fraction on the right-hand side. So now I have A times D, but I still have that B on the denominator, equals C by itself on the right-hand side. And I can do the same thing I did. So to get B times C, I'm going to multiply both sides by B, and remember that's the same as B over 1. So then the B will cancel on this side, and now I get A times D equals B times C, which is what I wanted. You can also prove properties 2, 3, and 4 on your own using algebra, and I recommend trying that if you're up for it. 4 is a little bit tricky, but 2 and 3 are very similar to what we did in for property 1. So, but number 4, it's a little tricky. It's kind of fun. So try it. All right, let's look at some examples of how we might use these properties. So our first example is just filling in the blanks. So if I know x over y equals 5 over 6, then property 1 tells me 6x is going to equal 5y. That's also called the cross product property. And it's kind of nice because 5 and y should always be, unless you have the plus sign, 5 and y should always be across from each other, and x and 6 should always be across from each other. So that should help us fill out B and C here. So basically I flipped my first fraction, so I'm going to flip my second fraction. So I'm going to get 6 over 5. And I can check y and 5 are still across from each other, okay? And x and 6 are still across from each other. So that's a good way to kind of quickly check your answers. And then the next one, I did the numerators as a fraction, so then I'm going to do the denominators as a fraction. Y over 6 and check. 5 and y are across from each other, x and 6 are across from each other. Great. And then my last property, I have numerator plus denominator over denominator, so I'm going to do the same thing. Numerator plus denominator over denominator, and I'd like you to simplify those answers, so I would get 11/6 there. Next example, solve each proportion. So to solve each proportion, what I'm going to do here is I'm going to use that first cross product property to go ahead and get rid of the fractions. So remember that cross product property is really essentially just multiplying both sides by both denominators. So if you want to do that instead of the cross multiplication, you're welcome to do that. But I'm going to do cross multiplication. So I'm going to get x times 7 equals 5 times 12. So 7x equals 5 times 12. So 7x equals 60. Divide both sides by 7. And I get x equals 60/7. So go ahead and leave your answers as reduced improper fractions because they're going to be the easiest to work with if you have to plug it back in. And they also include all of the decimal places. So if you put this in your calculator and give me a decimal approximation and you rounded, your answer is no longer exact once you round. So this is nice because it has all of the decimal places included in it. Okay, let's try B. B is a little trickier because I have two y's and I also have a plus sign. So when I do my cross product, I'm going to get 8y equals 4 times all of y plus 3. Then I'm going to distribute that 4, so I get 8y equals 4y plus 12. Subtract 4y from both sides. So 4y equals 12, divide by 4, and I get y equals 3. All right, next we're going to talk about scales. And scale drawings are basically when you take something and you just reduce it in size. So scale drawings typically are reduced in size. Sometimes they could be enlarged, I guess. And then the scale or the scale factor is just like our dilation factor that we talked about, right? So it's like how big or how small are we sizing this down? Okay, so my scale drawing is going to be a reduction or enlargement, but usually a reduction. Of a figure or actual thing that maintains proportions and angle measures. Okay, so our scale tells us what our scale factor is. So like how much is this being reduced? Okay, so it is a ratio that tells us the reduction size. So for instance, on a map, an example, on a map, I might say, the maps have the little keys on them and they give you the thing. So a map might be, map scale might say every 2 inches is 5 miles. Okay, something like that. Okay, so that's an example of a scale. All right, let's do an example. If you want to print a photo from your phone, what are the largest dimensions that would fit on an 8.5 by 11 inch piece of paper? So I measured my photo screen on my phone, and my photo screen on my phone, the ratio is 2.5 inches by 3.25 inches. You can either use my scales or you can use your own. I have an iPhone 11, I think. So let's take a look. So if I take a picture on my phone, 2.5 by 3.25, and I want to put this onto an 8.5 by 11 piece of paper. I'm going to erase this real quick just so I have some more space here. So there's a couple options here. So option 1 is if I match the 2.5, if I raise that to the 8.5, then the 3.25 might not stretch all the way down to make the proportions the same. Maybe it only stretches to there, and I'm going to have a little bit of black space here, okay, along the bottom so that my proportions of my photo don't get stretched. Or maybe if I match the 3.5 or 3.25 to the 11, and then I match the 2.5 to the 8, maybe that doesn't stretch all the way, and I have a little bit of black space on the side this way, okay? So unless it's perfect, unless the proportions are perfect, I'm going to be in one of the two of these scenarios. So let's talk about how that's going to work. So if I compare width to length, so 2.5 to 3.25, Then on my first scenario, I have 8.5. I'm going to make sure that that 2.5 stretches all the way to that 8.5, but I'm not quite sure how long this needs to be perfect. So we're going to call that X. Okay, so here I did the greens together and then the oranges together in this fraction. Okay, I'm going to do the same kind of proportion for my next one. So for my next one, I made sure that the 3.5, or the 3.25, excuse me, got stretched all the way to the 11-inch side. But I'm not sure about the 2.5-inch side. So 2.5 inches, we're going to call that Y. We're going to call this distance right here Y. We're not quite sure how far that's stretched. Okay. Oops, and sorry, my colors, I meant the orange goes on the numerator and the green goes on the denominator for both of these. Okay, so my green sides are on the denominator, my orange sides are on the numerator. Color coding really helps me a lot when I learned proportions. So if color coding helps you, do it. Get out your highlighters, your colored pencils, color code things. All right. Now let's do some math. Okay, so solving these proportions. So I'm going to solve option 1. So I'm going to get 2.5 times X equals, pull out my handy dandy calculator here because I don't know how to do this in my head. So 8.5 times 3.25 gives me 27.625. And then I'm going to divide both sides by 2.5. And I'm going to get that X equals 11.05. Ooh, that's not going to fit. My picture is going to go off of my page. Too big. Okay, right? Because my page is only 11 inches and I have 11.5 inches, 11.05. So just a little bit too big, but almost perfect. Let's try the next option. So the next option, I'm going to get 3.25y equals 2.5 times 11 is going to be 275. Divide both sides by 3.25. And I'm going to get, 275 divided by 3.25. Did I mess up? I think I messed up. I think this is supposed to be 27.5. So let me check that. 2.5 times 11. Yes, 27.25. Then divide by 3.25. Forgot my decimal there. It's quite important. So then I get y equals 8.4615, blah, 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 blah. So this one is going to work. It's going to fit, right? Because this is less than 8.5. So my final answer here for my dimensions are going to be 11 by 8.46 inches. 11, usually we list the smaller one first. So 8.46 inches by 11 inches would be my final one. That one would fit. The other one would be too big. If I made it go to 8.5 by 11, my picture would be slightly distorted, right? Because that's not going to fit either the length or the width of my photo. All right. So we say two polygons are similar. So similar polygons or similar figures if all the side lengths, okay, so similar, let's do this. Let me erase this. Similar figures have proportional side lengths and congruent angles. And the similarity ratio is the ratio of corresponding side lengths. Okay, so this is the ratio of corresponding sides. Okay, and it's going to be the same for all sides. Okay, if it's not, then they're not similar. Okay, so let's look at an example. So if quadrilateral ABCDE is similar, so this is our symbol for similar. Okay, our symbol is like the top part of the congruent symbol. It's just a little squiggle. Okay, so ABCD is similar to EFGH. Complete each statement. Okay, our first statement is the measure of angle E. Well, I know this angle has to be corresponding to this angle, and they have to be congruent. Similar figures have congruent angles. So that would be 53 degrees. Next one, AB is to EF, okay, as AD is to, well, that would be EH. Okay, use those colors. All right, next, determine whether the triangles are similar. If they are, write a similarity statement and give the similarity ratio. Okay, so I'm going to go through and I'm going to highlight my corresponding sides. So the side between one arc and two arc angles would be 15 to 20. So 15 here and 20 here. So that's my yellow one. Okay, and I'm going to go ahead and simplify that fraction. So if I get 15 over 20 reduced by a factor of 5, I get 3/4. Okay, let's look at my next corresponding side. So 2 arcs to 3 arcs. 2 arcs to 3 arcs gives me, let's see here, 12 on the top fraction, 16 on the bottom fraction. And if I reduce that by a factor of 4, once again, I get 3/4. So that was the green ones. And then I have 1 arc to 3 arcs and 1 arc to 3 arcs. So far, I'm good. Let's check this. So 1 arc gives me 18 and 3 arc gives me 24. Go ahead and reduce that by a factor of 6. And once again, I get 3/4. So yes, they are all similar, okay, because all of these are equal. I get 3/4, 3/4, 3/4. So yes, and my similarity ratio, you guessed it, is 3/4. And the similarity statement is kind of like congruent statements. So you just have to make sure that you list your things in order. So if I said A, B, C, similar to triangle, and now I just got to make sure I go in correct order. So A is corresponding to F, right? Because it's where the yellow and the blue meet. And then I go from the yellow, or from that to the, along the yellow, so B, so I get E, oh sorry, not E. E is the second letter. F-E-D. Great. Next. This one tells me that my two quadrilaterals are similar. Find the similarity ratio and the value for X. So I want to make sure I'm comparing corresponding sides. So I'm going to compare this side to this side. So I know LM over QR is going to equal 5/6. So that's my similarity ratio. It's already reduced. So now I'm going to use the same thing for the side that's corresponding to X. So I'm going to have ON over TS is going to equal 2 to X, which we know has to have that same ratio. So then my proportion would be to solve this right here. So I'm going to cross multiply on both sides. So 2 times 6 is 12 equals 5X. Divide by 5. Divide by 5, I get X equals 12/5. Okay, so go ahead and try the homework.